For section 3.6, you're going to apply the Pythagorean theorem to find missing side lengths of right triangles and in different situations. When you do this, you're going to make sense of problems and persevere in solving them. You will have a lot of application problems that you'll need to figure out which side length is missing, what you need to solve for. Some of them you'll have to draw it out to figure it out. So you'll have to persevere through all of that. So the Pythagorean theorem was derived by a Greek philosopher named Pythagoras. Pythagoras is known as the father of numbers when it comes to math. He has made a lot of contributions to math, and Pythagorean theorem was one of his greatest accomplishments. So the Pythagorean theorem is basically used for two purposes. The first one is to determine whether three sides form a right triangle. So if you have three side lengths, you can figure out if they form a right triangle or not using this. And then the other purpose is to determine a missing side of a triangle. So we're going to do both of these things in this section. So if you have two sides, you can always find the third if you have a right triangle. So a reminder, Pythagorean theorem can only be used for a right triangle, like what is shown right here. The formula is a squared plus b squared equals c squared. So that we always use a, b, and c to name our sides. A and b are the legs. They're the smaller sides. A is typically the smaller leg of the two, and B is typically the larger of the two. It does not have to be that way, but that's typically just how they get named. A and B come together to form a right angle. So here's A and here's B, so they form this right angle when they meet. The two legs of a triangle always will do that, of a right triangle will always do that. And then we have side C. C is called the hypotenuse. C is always going to be the largest side. So if you have three side lengths, you always know which one is C because it's the largest one. C, this is super important, C cannot help form the right angle. Notice that the two angles that C forms are not right angles. It's always going to be opposite from that right angle. It's always that diagonal. All right, so our first examples we're going to be doing the first purpose that we talked about. We're going to determine whether the three sides that were given will form a right triangle. So to do this, I have three side lengths right here, 3, 4, and 5. My first thing I need to do is figure out which ones are A, B, and C. Well, C is going to be the largest. 5 is the largest of those three, so it's C. A and B, it really doesn't matter which one is A and which one is B between the two legs, but typically we'll say that the smaller is A and the larger of the two is B. So now is when we're going to use the Pythagorean theorem. I'm going to use a squared plus b squared equals c squared. So I'm going to take A and plug it in for A right over here. So I now have 3 squared. Now I'm going to take B and I'm going to plug it in for B. So I have 4 squared right here, and I'm adding. And now finally, I'm going to take C and plug it in here. So my equation is 3 squared plus 4 squared equals 5 squared. And I need to see if this is equal. So I'm going to go through and solve this down. I know 3 squared is 9, and 4 squared is 16, so I have 9 plus 16, which equals 25. 5 squared is 25. So those two are equal. So that means that, yes, this is a right triangle. So that means it's going to look something like this. This is going to be a length of 3, that'll be a length of 4, and then this is a length of 5. Let's do another example. I have square root of 5, 4, and then square root of 10. So my first thing I need to do is figure out which one of these is my hypotenuse, which is my C. But I don't know, I can't just compare square root of 10 with 4 and with square root of 5. I need to figure out what those are. So I'm going to go through a short estimating process, and I'm going to think about square root of 10. Well, I know that square root of 10 is going to be between square root of 9 and square root of 16. Square root of 9 is 3, and square root of 16 is 4. So if it's between those two, then it's going to be 3 point something. 3 point something is less than 4. So 4 is bigger. I know that square root of 10 is going to be bigger than square root of 5. Since they're both under those square root signs, I can just compare the numbers. So that means that square root of 5 is the smallest, square root of 10 is the middle, and then 4 is the largest. So that means that 4 is going to be my C value, square root of 5 is the A, and square root of 10 is the B. So they're not always going to be given to you as A, B, and C. Sometimes they're going to be in a different order, and so you need to figure out which is which. If you choose the wrong C value, then your problem's not going to work out the way it's supposed to. So now I'm going to write out my Pythagorean theorem. A squared plus B squared equals C squared. And I'm going to start substituting my values in. So A is square root of 5. So I'm going to have square root of 5. I'm going to put that in parentheses so I know that whole thing is my A value, and I'm going to square it. Next I have B. Oh, that's not B. My B value is square root of 10. So I have plus square root of 10. Once again, I'm going to put that in parentheses so I know that whole thing is being squared. And then lastly, I have 4 as my C, so that's 4 squared. Now when I solve this down, I know that square roots and squares are opposite operations because we learned that earlier in this unit. So I know that the square root of 5 squared, well, that square root and that square are going to cancel out, and I'll just be left with 5. And then the square root of 10 squared, that square root and the square cancel out, and I'm just left with 10. And then 5 plus 10 is 15. Now working over to the right side, 4 squared is 16. 15 is not equal to 16, so that means that no, this is not a perfect square, or a right triangle, sorry. So that means that it's going to look something maybe like this. So maybe this is going to be square root of 5, square root of 10, and 4. You don't need to draw this out on your homework. I just wanted you to kind of be able to visualize what these triangles actually look like. All right, so that's how you figure out whether or not the three sides will form a right triangle. You just figure out what your A, B, and C are, and then you substitute them in for A, B, and C in the Pythagorean theorem and simplify it down to see if they're equal. If they're equal, then they are going to be a right triangle. If they're not equal, then they will not be a right triangle. All right, the next thing we're going to do is we're going to have a right triangle that has one missing side. So we're going to figure out what the missing side length is. When we do this, we are sometimes going to end up with a non-perfect square under a square root sign. And when that happens, I want you to estimate your answer, and I want you to write it in simplified form. So let's go ahead and go through this and see what this means. So looking at this first triangle, I have two sides that I know. I know that A is 4 and B is 12, but I don't know what C is. So what I'm going to do is I'm going to have my Pythagorean theorem, A squared plus B squared equals C squared. A is 4 and B is 12. All right, I got 4 there, and I've got 12 right here. So I just substituted those in for A and B. I need to figure out what C is. Since I don't know it, I'm just going to leave it as C in this equation. And now I'm going to solve this. So I have 4 squared, which I know is 16, and 12 squared, which I know is 144, and then that's equal to C squared. 16 plus 144, well, if I don't know what that is, I can go over to the side and I can write that out. 4 plus 6 is 10, 5, and 1. So that is 150, and that's equal to C squared. At this point, I know what I need to do. We've done this multiple times in order to figure out what C is, because I don't care about C squared. I need to square root both sides of this equation. 150. I can't take the square root of that because that's not a perfect square. So for now, I'm just going to say that C is equal to the square root of 150. So now is when I need to estimate that, and I need to write it in simplified form in order to get my full answer here. So I'm first going to estimate it. Now when I estimate it, that's when I'm going to go through that process and get a decimal that's not exactly square root of 150, because square root of 150 is irrational, but it'll be close. So I have square root of 150. The two perfect squares that this is between is square root of 144 and square root of 169. Square root of 144 is 12. Square root of 169 is 13. Now I need to take the square root minus the smaller. So I have 150 minus the smaller over the larger minus the smaller. So 169 minus 144. Now that gets me 6 over, this is 25. So I know that square root of 150 is 12 and 6/25. I know that because it's between 12 and 13. And then the 6/25 tells me the decimal portion of this problem. Now, in the past, what we've done is you've had to divide that out. I will let you go ahead and keep it as 12 and 6/25. But super important, these labels are all labeled with inches, so you need to say that this is 12 and 6/25 inches. So that's how you estimate. I'm going to make this a little bit smaller because we also have to simplify this problem. So I'm going to zoom in over here. Now we're going to simplify. So this is where we're going to have a square root in our answer still, but we are going to have smaller numbers that we're looking at. So the square root of 150, I have to do my factor tree. Well, I know that 10 times 15 is 150. And then 10 is 2 times 5, and both of those are done. 15 is 3 times 5, and both of those are done. Now I'm going to circle my pairs and connect them, and then box my singles. My pairs are going to go out. My singles will stay in. And so this answer is 5 rad 6 inches. So on these problems, there's 3 main things that I need to see. I need to see all of your work. I need to see it estimated, but you can leave it as a fraction. And I need to see it in simplified form. Let's do another one together. Next I have this triangle. I know A and C, but I don't know B. So I'm going to start by setting up my Pythagorean theorem. So I have a squared plus b squared equals c squared. My A is 8. I don't know my B. And then my C is 13. So once again, I got my A right here. I got the B right there, and I'm leaving it as B because I don't know what it is. And then I got C right here. All right, so I'm going to continue to solve this through. I have 8 squared, which I know is 64, plus B squared equals 13 squared, which is 169. Now I'm trying to get B squared by itself, so to do that, I need to subtract 64 from both sides. So on the left side, I'm left with just b squared because my 64's cancel out. And on the right side, I have 105. Now I need to square root both sides because I don't care about b squared, I care about b. And when I do this, my square root and my square cancel out, and I'm left with b is equal to square root of 105. That's not a perfect square, so I'm not going to get just a whole number. Because of that, now I have to go over here and I have to write my answer in estimated form and simplified form. So first I'm going to estimate. So I have square root of 105. Well, the two perfect squares that's between is 100 and 121. Square root of 100 is 10. Square root of 121 is 11. So this number is going to be between 10 and 11. To figure out what the fraction is, I'm going to take the square root minus the smaller. So I have 105 minus 100 over the larger minus the smaller. So over 121 minus 100. And when I do that, I get 5 over 21. So since this is between 10 and 11, this is 10 and 5/21. Remember, for this, we can leave it as a fraction, but we need to look over and see that this is in feet. So I need to write 10 and 5/21 feet. I'm almost there. I just have one more step I need to do on this problem. I need to simplify it. So let me make this smaller. And now to simplify it, I need to make my factor tree. So I have square root of 105. Well, I see that that ends in a 5, so I know it's divisible by 5. To figure out what it's multiplied by, I need to divide. 5 goes into 1 0 times. 5 goes into 10 2 times with nothing left over. And then 5 goes into 5 1 time with nothing left over. The 5's done. And then the 21 is 3 times 7, and both of those are done. When I go to box in my singles and circle my pairs, I notice that I only have singles. So that means that since there's no pairs, they all just stay inside. So this would be square root of 5 times 3 times 7, or just square root of 105. And don't forget to put your label on that. So if they're all singles when you do the factor tree, then that means that it stays as that original square root. That is as simplified as it can go. So right there are your two answers to this problem. Make sure when you do problems like this, I can see your work, I can see it estimated, and I can see it simplified. All right, we have one more left on these notes of problems like this. So what I want you to do is work this problem out on your own. So pause this video, work it out, and then once you're feeling pretty confident with this, then play the video, I'll work through it, and you can check and see if you were correct. All right, so this triangle, I don't know my A, I know my B, and then I know my C. So I need to first write out my Pythagorean theorem. I have a squared plus b squared equals c squared. I need to now substitute in my numbers. I don't know a, so I'm leaving this as a squared. My b is 100 square root of 157. So I need to be really careful here. I have square root of 157, and then I'm going to put that in parentheses so that I know that whole thing is my v value, and then I'm going to square it. Don't forget the exponent right there. And then this is equal to c squared. C is 15, so it's equal to 15 squared. So my a is right here. And I'm not sure what that is yet. My b is right here. And then my c is right here. So make sure that you're substituting those numbers into the correct spots. Now I'm going to go through and I'm going to solve this. I have a squared staying as a squared. Square root of 157 squared. Well, I know that square roots and squares cancel out, and so that just leaves me with 157. And then on the right side, I have 15 squared. And so I know 15 times 15 is 225. Now I need to finish solving this, so I need to subtract 157 from both sides. I'm not quite sure what 225 minus 157 is, so I'm going to go through that process and simplify it. On the left, I have a squared. On the right, I need to do some borrowing in order to subtract. So I need to borrow over here, This becomes 12, but I need to borrow again, and that's 15. 15 minus 7 is 8. 11 minus 5 is 6. And then 1 minus 1 is 0. So a squared is equal to 68. Now I'm going to take the square root of both sides to figure out what a is. And so a is equal to square root of 68. And I don't know what square root of 68 is yet. So now I need to come over and I need to estimate my answer. So to estimate it, I'm going to start with square root of 68. Well, I know that that's between square root of 64 and square root of 81. Square root of 64 is 8. Square root of 81 is 9. So that means that this number is between 8 and 9. Now to figure out my numerator for my fraction, I'm going to take the square root minus the smaller. So 68 minus 64. And then to figure out my denominator, I'm going to take the larger minus the smaller. So I have 81 minus 64. And so that is equal to 4 over 81 minus 64 is going to be 17. So I know that the square root of 68, since it's between 8 and 9, is 8 and 4/17. I don't need to divide out that fraction, but I do need to see that this is in meters. So this is 8 and 4/17 meters. Next, I need to simplify this, so I need to do my factor tree. Let me give myself a little bit of space. So the first thing I need to think to myself is, what two numbers multiply into square root of 68? Well, I see that that's an even number, so I know that 2 is going to be one of them. 2 goes into 6 3 times, and 2 goes into 8 4 times. 2's done. 34, once again, is an even number. So I have 2 and 17, and those are both done. Now I'm going to circle my pairs and connect them and box my single. So I have my pairs go out and my singles stay in. So this is 2 rad 7 meters. So that is this last triangle. We only have one more problem left, and it's a word problem. One thing I want to point out is on your homework for this section, you have, I believe, 6 word problems that you need to complete, and you must complete at least 3 of them. So you need to know how to do these. This is an important part of this section. This is where you're really going to apply this stuff. So let's look at this problem. A bus travels 60 miles west and then 20 miles north. How far is it from where it started? So what you're going to do is you're going to draw a picture, label it, and then solve. All I want is your answer in simplified form. So you're not going to estimate. You won't do that. You just simplify it. So the first thing you need to do is draw a picture. First of all, let me think what my directions are. I know that north is up and south is down, and then east and west. So if I have a bus that starts right here, and it goes 60 miles west, and then it goes in this direction, 60 miles. And then from there, it goes 20 miles north. So it goes 20 miles north. This question is asking, how far is it from where it started? So if it started here, and it ended here, we want to know, what is this distance? Well, look at this. I notice this is a right angle, so I have a right triangle. So if I have 2 side lengths and I'm missing one of this right triangle, then I can use Pythagorean theorem to find that missing distance. So what I need to do is a squared plus b squared equals c squared. I notice that I'm missing the hypotenuse, I'm missing the diagonal, which means I am missing the c value. So I need to substitute in 20 for a, and then 60 for b. And I'm solving for c. So now I'm just going to go through and I'm going to solve this. 20 squared, 20 times 20. Well, I know that 2 times 2 is 4, and then I'll have 2 zeros. And then 60 squared, well, I know 6 times 6 is 36, and I'll have 2 zeros. And then this is equal to c squared. 400 plus 3600 is going to be 4,000. That's equal to c squared. Now I need to square root both sides. Square root of 4,000 I don't think that that is a perfect square. So I know right now that square root of 4,000 is equal to c. So that means I need to simplify this. So I'm going to go over to the side. I'm going to do my factor tree. So I have 4,000. Well, I know that that is 1,000 times 4. I know that 1,000 is 100 times 10. And I know that 100 is 10 times 10. And then 10 is 2 times 5 and 2 times 5. Now all 4 of those are done. 10 again is 2 times 5. And 4 is 2 times 2. All right, I've got to be really careful here. I have a lot of numbers. Well, right off the bat, I see this pair. Then I see I have 2, 5, 2, 5, so those are a pair. Those are a pair. And all I'm left with is this last 2 and 5 right here. So those are both going to be singles. So when I write this, I need to be very, very careful. I'm going to take these out. Next, I'm going to take these out. Next, I have this pair that goes out. And then lastly, I have my singles that stay in. And now I just need to multiply this out. And so 2 times 5 is 10. And then 10 times 2 is 20. And then 2 times 5 is 10. All right, that's the last for this section. So as a reminder, you have these word problems. You need to find missing side lengths, and you need to determine whether these are right triangles. You are good to do the homework now. If you have any questions, like always, talk to me about it. Let me know.